We recommend that the e-Boost2 is set up on a dyno. We're at Pulse Racing to set up the e-Boost2. First, we're going to start by setting up the SP values to determine what the maximum level of boost we're going to achieve, and then we're going to start playing around with the gate pressure to increase the response of the turbocharger. First thing we need to do is get into the boost menu by pressing the mode and boost button. So as you can see, boost group 1 is shown. Press mode to get into it, and that will display the SP value. To adjust the SP value, press mode to get into it. So first what we'll do is we'll leave it at 0 and see what the car makes on wastegate spring force. So if we press the mode button till we get to peak hold boost, we can see our maximum is 12.6. So our target's around 18 pounds, so we'll turn it up. So get into the boost menu setting again by pressing mode and down, get into boost group 1, and we'll start by adding 20 numbers to it. So by going into the peak hold boost setting again, we can see that our maximum boost has now risen to 13.4, which is far away from our target. So we'll turn it up some more. We'll add another 20 numbers to it and ramp it up. Okay, so we're getting much closer to our target boost pressure now. Another way to tune boosts is when you're in the SP value menu, while the car is on boost, you can continue to press up, adding SP values, but what you'll see is the actual boost pressure going up, and you can set the boost up like that. So this is what we'll show you now. All right, ramp it up. So as you can see, the SP value we got to was 51. And the maximum boost we got to was 17.8, which is extremely close to our target. So now the boost is set. The next thing we do is play around with gate pressure to improve the response of the turbocharger. So by entering the boost menu again, scroll up to see GP1. Factory set is at 3 psi. We like to set it about 3 psi below target boost as a starting point. So if our target is 18, we'll set it at 15. Save the setting by pressing mode. And ramp it up again. So now we can clearly hear that the response of the turbocharger has changed and it ramps up a lot quicker. So as you can see, by increasing the SP value, you can effectively increase the boost the turbocharger makes. At an SP value of 0, we achieve this line. At an SP value of 20, we achieve this level of boost. At an SP value of 40, we achieve this level of boost. And finally, at an SP value of 51, we achieve our target boost of 18 psi. As explained earlier, the gate pressure changes the response of the turbo by clamping the signal to the wastegate till a certain boost level is reached. This keeps the wastegate closed until the user wants the wastegate to open, aiding in response. Gate pressure is set at a level below target as the wastegate needs time to open to catch the boost curve. If gate pressure is set too high, such as at your target boost level or over your target level, then boost spiking will occur. As you can see with this boost graph, by changing the gate pressure from 3 psi to 15 psi, we got a much sharper increase in boost. The sensitivity is factory set at 20, and since we achieved a flat boost curve, no adjustment was needed. The sensitivity determines how sensitive the e-Boost is to changes in pressure. When the sensitivity is set too high, small changes in pressure result in the e-Boost overcompensating in duty cycle, resulting in oscillation. Sensitivity set too low results in larger boost drop-off in high RPM since the e-Boost is not compensating for changes in pressure. Most setups use a sensitivity of 20. We found with the responsiveness and wastegate size of the standard Evo 8 Turbo, we needed to use a sensitivity of 3 to achieve a smooth line. Since with the external wastegate setup and the larger turbo, our boost curve was relatively flat, so sensitivity was left at 20. As you can see here, there is a slight boost drop-off as you reach a certain RPM all the way to redline. This can be adjusted and compensated for with the e-Boost correction feature. So what you do is you input the RPM at which boost is beginning to drop off and where redline is, and by how much percentage wise is boost dropping off by. So for example, if your target was 15 psi but at 5,000 RPM and 7,000 RPM boost was dropping off to 10, then that's a drop off of 33%. So in the boost correction menu, you would add the start RPM at 5,000, the end RPM at 7,000, and the factor of 33%. That should effectively reduce or eliminate the amount of boost drop off you have. So we've given the car to Pulse Racing to work their magic, and this is what they've come up with. Paulie, would you explain what you've done?
No worries. Basically, what we've done is a custom pulse edit tune. The boys left it in our hands for a bit of time, and we're able to work our magic and obtain 233 kilowatts out of the engine. As you can see from the red line, the standard Evo came in with about 194 kilowatts. The boys from Turbosmart left the car in our hands. We're able to do a custom tune on it, which is the blue line, making 232 kilowatts. We're able to increase the boost. Great reliable car, very fast car, great on fuel economy, drivability, can be taken on the track, also down the quarter mile. Very, very fun car to drive as a daily driver.
That's all we've got time for today. Thanks Paulie and the Pulse Racing boys for doing this tune for us.
Not a problem, my friend, and the boys at Turbosmart, welcome here anytime.